So in the last lecture, we looked at examples of questions where you were given an equation of a parabola and asked to come up with information about it, to find the location of its focus, of its vertex, all those other parabola properties. In this lecture, we're going to go the other way. In this lecture, I'm going to give you information about a parabola, like the location of some of those objects. And the question is going to be, find the equation of a parabola that has those properties. All right, so going the other way now, right? Find the equation of the parabola whose vertex is at 0. So we're starting with this same setup, right? The vertex is here, and whose focus is at -5, comma 0. So I'm going to go -5, 1, 2, 3, 4, 5, comma 0. There's the vertex. There's the focal point. Okay, so again, right, I'm always going to start off, I'm a very visual person, always going to start off with a sketch. I know that the focal point has to be inside the parabola, right? Well, if it's going to be inside the parabola, then it needs to be this left facing one. Okay, so now I know the general shape. What is the general equation of a left-facing parabola? Well, the left and right ones, those have a y squared and an x, and the left one has the -4a. All right, so all I got to do is figure out a, and I'm home free. Remember, a is the distance from the focal point to the vertex. That's going to be 5, and it's +5. It's a distance, right? Always think of this a as a distance, so it's always going to be a positive number. So if I put 5 in here, I get y squared equals -4 times 5, which is -20, x, and that's it. There's my equation, right? There's the equation of this parabola. Look at this thing. I want to find the equation of a parabola whose vertex is someplace other than the origin and whose focus is at 3, 4. Okay, well, let's sketch this. I'm gonna go over 1, 2, 3, down 2. There's my vertex, right? And I know the focus is at over 3, up 4. So I'm gonna go up 1, 2, 3, 4. There's my focal point. Okay, so good. Now I know my parabola looks like this, right? Because the focus has to be on the inside. And I know that this distance here is A. So A equals 6. So here's what I'm going to do. I'm going to find the equation just like we did before, right? Just like we did before when the vertex was at the origin. Then all I'm going to do is I'm going to translate it, right? So this is an upward opening parabola. So I know that my equation is x squared equals 4ay, and y was 6. So it's x squared equals 4 times 6, that's 24y. Okay, so this parabola, the parabola that goes with this equation, looks identical to the one I'm trying to find, only it's over here instead of down there. Okay, well, to get it there, I'm just going to do a translation. I need to go 3 units to the right. So I'm going to replace the x with x minus 3. Oops, not plus, equals 24. And I need it to go 3, where's my vertex? 2 units down. So I'm going to replace the y with y plus 2. And that's it. There's my equation. Now, I am perfectly happy with the answer being left that way. Okay? Other professors may feel differently. If you're using that MyMathLab program, for example, I know MyMathLab feels differently. They may want you to multiply this out, combine like terms just one time so that you can see what that looks like. I'm going to do it. All right, but for my purposes, if you left it like this, I would have been perfectly fine with this as an answer. So let's see. If we multiply out this left side, this is x minus 3 times x minus 3, right? So that's x squared minus 6x plus 9 equals 24y plus 48. And then let's combine some stuff. Let's subtract 48 from both sides. X squared minus 6x minus 39 equals 24y. And then ultimately we're solving this for y. So if you divide both sides by 24, y is x squared minus 6x minus 39 over, over 24. Not sure why the view changed there, but that's okay. So again, this is not, to me, anyway inherently better than this. I would take this for an answer. Other people may expect you to go and do this instead. So let's look at another one. Here, we know the vertex and we know the directrix. So again, let's start with the same process, right? I'm going to graph this. The vertex is at over -2 up 1. That's up here. And the directrix is at x equals 2. That's right here. Okay, so the parabola will go through the vertex. So it's going to look like this. It's going to be opening to the left. And I know that my opening to the left equation, it's going to have an x and a y squared, right? So it's going to be y squared equals, then because it's going to the left, I'm going to have -4a over here. All right, now what is a? A is the distance from the vertex to the directrix. That's 4, which remember is the same as the distance from the vertex to the focus, right? So whichever one you've got, that's fine. That's the one we can use. So my equation is looking like y squared equals -4 times 4. That's -16x. Now, that's not really my parabola, right? That is this parabola. So I just need to move it over, right? I need to shift it 2 units to the right. So this will be -16x plus 2. And I need to shift it 1 unit up. So this part becomes y minus 1. And that's it. Stop. Don't multiply it out for my sake. I'm perfectly fine with that as the final answer. So the next lecture, we're going to continue this process of finding the equation of a parabola. And we're going to do it in more general terms. Instead of having these really kind of very specific properties, we're going to look at the question, well, what if we just have some points? This is the kind of thing that comes up in statistics and data analysis, right? You know some data values. And you want to find the equation of a curve that fits them, the equation of a curve that goes through those points. In the next lecture, we're going to see how to do that when we believe that the equation is going to be the equation of a parabola.